I would request everyone to put on your videos if possible, because that transmits energy to each other and we would be more energetic in learning. Thank you so much, all the known faces, to come up again and turning up again after a gap of 6 months. This further, your presence further belief strengthen my belief that age is not a barrier in new learning. It is always the attitude and our fire inside your belly which motivates you to learn new things each day and every day. So friends, I think you need to pat on back of yourself and say, I'm a good learner. Please do that. Friends, today we have a surprise for you after end of this webinar. We are bringing a knowledge of powerhouse with a new series of webinar on a variety of topics which are very, very innovative. The topic of that series is innovations. And that particular series is analyzing the need, problem, and desire of the customers on air pollution control, and also suggesting a way forward for being future ready to face the more stringent norms in near future. So please, I request everyone to stay connected till end. We have a great announcement with 4 webinars with scheduled date and their topics. And today's webinar is a pre-launch webinar of that series, is basically to control on a most notorious air pollutants which exist in the vicinity is called SOx, or we call it sulfur dioxide, SO2 or SO3. We shall be learning its various sources, the cure and the precautions and the prevention of the SOx in this particular webinar with the new technologies which are prevailing, particularly with respect to the process boilers and the boilers in the captive power plants in the lower side, lower range, maybe up to 100 or 150 megawatt. Because for the bigger power plants, people are clear that NTPC is doing a lot of projects on wet FGDs and all. But the people who have a lower size of power plants or in the process plants, the selection criteria is becoming very, very, difficult for them, which technology to go, which not to go. So there is a lot of confusion among the users. So today's webinar is going to be focused on the selection criteria and also going to spell out on various type of technologies which are available to control SOx emissions from your boilers. So friends, before I start, let me just remind you the ground rules. Please maintain a high energy because the energy and learning are directly proportional. Use your fingers for typing the message in the chat box as and when required so that you stay connected and I also get energy from you. And I also expect everyone to keep your phone on silent mode, be energetic and be active on the chat box. And the last but not the least, please honor the IP and do not click the pictures of the slides. Whatever portion of the slides require, please put it in the chat box. My team will ensure that it reaches to you in next 48 hours. So thank you so much. We are starting the webinar of today on SOx abatement system. I'm going to share a screen with you. So guys, are you ready? If yes, please write ready in the chat box so that I know that you are on the same page. Thank you. Thank you for your response. I hope the screen is visible. Please just give me a signal if the screen is visible to all of you. Just write visible in the chat box. Okay. So today we are talking on SOx abatement system, particularly for captive power plant and process boilers. Before I proceed, let us understand the sources from where this sulfur dioxide emissions are mainly coming and polluting the atmosphere. And if you look at the data, the combustion of fossil fuel is the main source of creating these SOx emissions. 90 to 95 to 96% of the sulfur is converted into SO2. The sulfur present in coal, oil, or other fossil fuel that gets converted into SO2 during the combustion process. And if you look at the sulfur content in Indian coal varies from 0.25 to zero point 0.5, and imported coal, it is still higher, 0.6 to 1%. And if you look at the coal with 0.5% sulfur content, that gets converted into SO2 to the tune of 1.5 to 2 grams per normal meter cube of flue gases. So you can see how this conversion of sulfur is taking place into the sulfur dioxide gas and creating a pollution in the environment. So main sources, as I told you, are the combustion of oil, gas and petcoke, metal industries from the smelter plants, sulfuric acid plant, WTE plant, waste to energy plant, firing, municipal solid waste or residual fuel. Or another source is vehicular pollution and industrial processes. But if you look at the data, the major source is the thermal power plant firing coal or lignite in India or even abroad. So look at the percentage. The 67% of the SO2 combustion is attributed to the fuel combustion of fossil fuel, whereas the vehicle pollution is limited to 1.3% and 0.6% and 2.3%. So all put together is about 4%. And out of this combustion, the major source is the coal and oil, which constitutes to about 50%, a little less than 50%, around 45% SO2 emissions in the atmosphere. And how these SO2 emissions are affecting our health or the human. If you see the effect on environment and on the human being for these SOx emission, you will be surprised that it creates a lot of diseases, it creates a lot of irritants in the body, human body, and also spoil our monuments and all. So the major diseases are, it creates an irritation of skin, eyes, nose, throat, and lungs. And serious complications are also there in the respiratory system. Inhaling can even cause death. If you inhale more than the desired quantity, it can cause a death also. And it also has an adverse effect on environment. You can look at this, how this acid rains are there because of the SO2 emissions from the plant, and that gets spoiling our soil, it's spoiling our water table, and it has multiple effect on environment. On the human health, if you see the SOx and NOx emissions, both are creating a lot of issues with respect to the respiratory illness and cardiovascular illness also. Friends, this SO2 is not only creating trouble to the human, to the plants, and to the other bad effects, but also having effect on our monuments. You can see the condition of Taj Mahal 20-30 years ago, and as on date, it is slightly going yellowish in color. So this is all because of the sulfur dioxide emitting from Mathura refinery near to Agra. If you look at the condition from 2005 to 2016, this data is up to 2016 with me right now, and you can see how this SO2 spots are increasing, particularly in eastern part of the country, where this cluster of power plants, this coal-based thermal power plants are there, steel plants are there, the big power generation units are there. So you can see how from 2005 to 2016, we have progressed on emissions on SO2. And if you look at the this state wise, you can see the major concentration is near Singrauli, where the power plants are there in Madhya Pradesh, and this is emitting the highest amount of SO2. And then so on, you find this Singrauli, Korba, Raigad, which is the hub of these steel industries or the thermal based power plants. And why I'm saying that it is all human created and it is not natural. You can see this graph from April 2019 to April 2020, the difference. And what was there in April 2020 and 19? April 2020 was the pandemic lockdown one. This indicates that this is all created by we humans. And this is, if we have created this, we have extra responsibility to curtail this and to give it back the same planet and what we used to have. So the onus is on all our industrialists, all the technology providers, and all technologists to attack this problem and resolve it. So friends, these are the issues, various issues related to the SOx emission. I hope I've been able to establish the need so far, why it is required to eliminate or reduce or minimize this SO2 emissions from our climate. This is not only creating problems in human health, but also is spoiling our nature, is spoiling our planet. So hope, friends, so far we are clear on our need, on our problems, and on our desire. What is our desire? Our need is to control this as per the CPCB norms. Our desire is going to be like that we should control it within the most economical way. We should control it in such a way that it does not have effect on the uh, uh, upstream or downstream system of the plant. So these are our desires, and problem we know, and the need also is very, very clear. So friends, before I go to the solution, how to resolve this and what are the technologies available, I would request everyone to just be a part of little survey. My backend team is going to share a link. We will have a 3 minutes for filling up those questions. It is a very simple 3-4 questions. Just write in that your response, so that we know and we can know more accurately your desire and need, and accordingly we can focus on our presentation in the next stage. So what are the problems among the people or among the plants who are attending this webinar? So I request, I'm just de-sharing it, and I'm requesting our team, Prakhar, can you please share the link in the chat box so that everyone can fill it, and then we have a 2 minutes break for that. Over to you, Prakhar. So friends, open this link. Everyone, please open this link and fill this survey form. It's a very simple questions. Please put on your video on, that would be better for us to communicate. And I'm seeing a couple of my friends from overseas friend from Vietnam. Thank you, Swain. And from Thailand. Thank you, Thitiwat and all, for joining. I know it is a odd time for you in Vietnam, Thailand, and other places, but still you are joining. That shows your willingness to learn the new technologies and gain knowledge. Thank you so much. So friends, I hope you are all filling up this form. These are very basic questions which will give us a little bit of idea about the requirement, about your problems, about your need and desire. If anyone is having some problem in downloading this link, please write in the chat box. Otherwise, if you are filling, it is okay. We will have 2 minutes more to have that filled completely. Okay, let me just set it right. I think a couple of people are not able to open the link. Prakhar, can you put it again? What about others? Some people are filling already. We have already got many responses. Whosoever has not filled up yet, please do so. We will take another 1 minute and then close this survey. Okay, thank you so much. We have already got more than 25 responses, and whosoever has not been able to do it, do not have to worry. Our team will send you on your email, and then you can respond back on email. Okay, thank you so much. So friends, having done and having established the need, desire, and problems of the plant owners or the plant operators with respect to the SOx emissions particularly, we have designed this particular webinar to let you know about the existing and prevailing technologies and then give you a criteria for selecting the right technology for your plant. Okay, so and after that we will be giving you a comparison also at a glance. So this is what all is included here. So I'm moving ahead. So we know the problem, but we do not know the solution. So what is the solution? How to control these emissions? And the solution lies in the flue gas desulfurization systems. We normally call it as a FGD systems. So what are the prevailing technologies on FGD? You know, there are three types of technologies which are popular in the market. This is wet FGD, semi-dry FGD, and dry FGD. And after that, there are other three more type of FGDs which are not so popular, but they are being installed in stray cases in some plants, particularly ammonia-based in fertilizer, seawater-based FGDs on the coastal areas, and then magnesium-based FGD depending on the sorbent available with that particular plant. So friends, wet FGD, semi-dry FGD or dry FGD can have different kind of sorbents. It could be a limestone based, it could be hydrated lime or a caustic based solution. And if you look at the numbers or the stats of type of FGDs all over the world, then you find that wet FGDs contribute to about 87% of the total installations in the world, whereas 11% are dry or semi-dry and 2% are other. On the reagent side or the sorbent side, if you look at the 55% is on limestone based, 33% is on hydrated lime, and 12% is others. Others includes your caustic or magnesium or any other sorbent. This is the stats of the world scenario at a global level. And if you look at the technologies at a glance and the comparison, basic comparison, then you find that wet FGDs, wherever you need an efficiency of 98% plus 98% plus SO2 removal, and wherever the high sulfur fuels are used, the coal containing 1.5% or above, and you have a blending of fuel, different kind of fuels, and you need a marketable byproduct, because wet FGD is only system which produces gypsum, the marketable product byproduct. And most of these wet FGDs are designed on limestone. Whereas the other semi-dry type of system is a basic system which is called SDA, spray dry absorber. Here the efficiency is 95% plus, and it is usually used for the fuel having less than 1.5% sulfur content. And the dry product is a landfill, and it uses normally hydrated lime. And then the upgraded version of semi-dry technology, and which is the most versatile, is called the circulating dry wet scrubber. This is called CDS. And this is the most popular type of system in the semi-dry technology, which can have the efficiency as high as wet system, that is 98 plus. It can be used for high sulfur fuel contained fuel. This also has got a lower consumption of solvent because of this recirculation of solvent back to the system. Dry product is again the landfill, same as the SDA. And this also uses lime or hydrated lime for the absorption of SO2. And the other type of system is an absolutely dry system, which is called a sorbent injection or DSI, dry solvent injection. And this dry solvent injection is also used, normally sodium is used as a base material, or sometimes lime is also used. But in most of the places, the sodium is a more popular sorbent when DSI comes into the picture. And it is injected before the ESP, after the boiler. And this can also remove your other pollutants in the form of acid fumes like HCl. So this is the basic, very basic comparison of these four type of systems. But when you really sit on this, it is very difficult to select which one to use where. It looks very simple, but when you work out for a particular plant, there are so many variables which comes into the picture and creates a lot of confusion among the users that whether he should go for a wet or dry or semi-dry. So we are trying our best to reduce or minimize that confusion today, so that your selection criteria becomes very, very clear. So I would just give you a little bit of the brief about every technology, especially on wet. And Guys, if you are following me so far, please write in the chat box. I need to just check if I am audible, if I am clear, or if you have anything. Please park your questions for the Q&A session, and that you write the question at the time of Q&A session only, so that we can look at in one go and reply that one by one. So if you are okay and clear so far, please write clear in the chat box. Thank you for your response. Yeah, so we are talking on wet FGD, how it works and what is the chemistry behind it. I would just like to explain you that this is a absorber, which is called the this FGD absorber. This is the main unit of the complete system, and it has a lot of sprays, nozzles, and you have multiple decks followed by the demisting section. And this slurry, this is the gas inlet, which is laden with SO2, and here this recirculation is there. The alkaline limestone slurry is spread, and with this limestone slurry is atomized, and then it comes into the contact of the sulfur dioxide gas, and it gets converted into CaCO3 and CaSO4, and then the CaSO4 is converted into the gypsum through the oxidation, and then some amount of bleed is taking place to control the chloride content and the content of solids in the recirculation path. And at the outlet, after the demisting process, you have a clean gas free from SO2 and the sulfur emissions. If you look at the chemistry step by step, you can look these equations. First, if the absorption process, where the SO2 reacts with water and then gets converted into HSO3, and then it is a limestone dissolution which takes place in the form of CaCO3, which is the limestone, and then creation of calcium sulfide, CaSO3 is formed, and then CaSO3 is converted into calcium oxidation in the bottom chamber, which is called a oxidation chamber or the reaction tank. And after the oxidation, the gypsum is separated, and gypsum is dewatered through a dewatering system, and then it becomes a saleable product for you, and the clean gases goes to the demister back to the stack through a booster fan. So friends, if you see the absorber chemistry, it is very, very simple. That limestone, the calcium is CaCO3 is reacting with sulfur dioxide, converting into the gypsum. That is the crux of the whole chemistry. But if you look at the finer point of this equations, you find that particle size of the solid limestone particles is a very, very important criteria here. The finer is the particles, the better is the reaction, because you get more surface area for absorption, correct? And then reactivity of limestone, that is nothing but the percentage or the purity of CaCO3 in the limestone that gives a better dissolution. And the pH value of the observer slurry, you need to maintain certain pH value in the recirculation slurry system. The lower pH leads to the faster limestone dissolution, but at the same time, higher pH also creates problem of scaling and other things. So there has to be a perfect balance, and this is one of the most important control parameter of operating a wet FGD system. So if you look at this, high pH value is good for the efficiency, the absorption efficiency, but at the same time, the dissolution rate of the regenerated limestone reduces and also creates scaling issues in the system, correct? Whereas the low pH value is detrimental to the removal efficiency, but beneficial for the limestone dissolution. So these are two reverse things in each other. If you maintain low pH, you have a problem. If you maintain high pH, you still have a problem. So there has to be a balance. And over the years, the experience has shown the pH value of 5.7 is the perfect balance for operating the FGD at a good efficiency and as well as avoiding the issues of high scaling in the system, in the nozzle, in the piping and other places. So many of you must be surprised that 5.7 is a pH which is acidic in nature, and still we are removing the sulfur dioxide. So this is what is the chemistry lies here, that maintaining 5.7 is still can remove the sulfur dioxide from the system and also balance the operating troubles which may appear at a high pH value. So I hope you are clear on this. Let me just take you to the wet FGD system components, or in the islands we call it. One is the main unit is the absorber, which is normally made is rubber lined carbon steel or the glass flake lining because of the pH, or sometimes it is have duplex steel depending on the budgets and depending on the amount of life expected from the system. And then pipings are normally in non-metal or as high-grade SS. Mist eliminator can be in FRP or in SS, high-grade SS. And similarly, the headers and normally this HEST alloy is being used in all the projects of NTPC, the HEST alloy lining, which is called C276, very costly material. But for the life, the HEST alloy lining is being used in the absorber. Then you have a demister, or we call it a mist eliminator. It can be of different type. It can be of chevron type. It can be of jet type. So this is the jet type you see here. And depending on the particle size or the mist size, this selection criteria is based on the particle size of the mist, basically, and the efficiency requirement. So, and the metallurgy, you can have non-metal, and also you can have in metal, in a stainless steel, high grade duplex steel. And then you have a recycling system which contains the nozzle, special nozzles of silicon carbide, and which can have a good atomization of the slurry. And then the piping system, which is normally on non-metal in most of the cases, or you can go then high grade metal conditions. This is the overall picture or the flow diagram of the complete FGD, wet FGD system. Normally, after the ESP, after the particulate matter is removed from the gas stream, a booster fan is used, and the gas goes to the absorber, and from the absorber it goes to the chimney directly through the demister. And the bottom part, you have a reaction tank, which is a absorber tank, and here we maintain some retention time for the reaction to take place for the proper conversion and crystallization of the gypsum material. So normally 3 to 5 minutes of retention time is required here, and this this is pumped to the hydrocyclone for dewatering, followed by a horizontal vacuum belt filter for removal of gypsum, or dewatering of gypsum and disposal of gypsum. And then the filtrate from this is taken back to this absorber tank, and there is some amount of this air is there. This is called this air oxidation blower. The air is given for the oxidation purpose to convert CaCO3 into CaSO4 and then convert into the gypsum. And some amount of this slurry is taken to the bleed, and the parameter which controls the amount of bleed is the chloride contains and the solid content which is there in the recirculation path. So this island is basically to the silo system for the feeding of limestone silo, and then you have a ball mill, and then limestone powder storage, and then it pumps to the absorber tank. I hope so far you are clear on this. If yes, just give me a signal and write clear in the chat box before I proceed to the next slide. Thank you. So if you look at the individual island, you find first is the reagent preparation island. As I showed you, it has got a day bin, and then it has a ball mill classifier, ball mill, and then feed tank for preparation of slurry. Normally 20% solid concentration slurry is prepared and fed into the absorber tank as a regeneration of the existing slurry coming from the scrubber. And the another island, one is the absorber island, and one is, as I showed it to you, the preparation reagent preparation island, and the third island is a dewatering island, which which dewaters the gypsum and then dispose it off through a HVBF belt system, vacuum belt system, and hydrocyclone. And as you know, there are multiple uses of the gypsum which is sold in the market. It can be used for the wall board, cement, plaster of Paris, soil conditioning, and hardening retarder in Portland cement. So multiple uses are there, but it depends on the quality of gypsum which you are producing, the moisture content of the gypsum. So accordingly, the price in the market is there. And if you have a good quality, you get a better return, and which can compensate some amount of your capex over a period of time. And as regard to the control system of the whole wet FGD, it is a first is the waste water treatment. As I told you, the control of solids as well as the control of your chloride defines the wastewater treatment quantity of wastewater or the bleed. On the control side, you have a dedicated DCS or PLC based system normally. And the control points is the first is the draft control using a booster fan, so that your boiler is not affected because of the extra pressure drop which is created. The fan can be before the absorber, and it can also be after the absorber, depending on the layout, depending on many other factors. This location of booster fan is decided. Then you have a scrubbing liquid pH control, which is very, very essential and very, very critical component of the whole system of wet FGD. You have a set parameter of 5.3 to 5.8 pH is maintained by controlling the recirculation rate and the rate of regeneration agent. And then you have a gypsum bleed solid control. If solid is too low, potential for gypsum scaling. If solid is too high, this increases the potential for wear and tear of the equipment. So there has to be a specific range of solid concentration, which varies from 14 to 16% by weight. So this solid concentration is to be maintained in this range. Then booster fan control, and then the last control, which is there to prevent the absorber internal parts, which are sometimes or in many installations are non-metal. So to control the temperature of the inlet gas, there is a quench water spray system, which is interlocked with the outlet flue gas temperature. So if the outlet flue gas temperature is going high, the water starts spraying here to control the temperature up to a certain limit to prevent the internals or the non-metallic parts of the absorber. So if I summarize the wet FGD, it is a system which is the most commonly used for high-sized power plants, because the OPEX is the most minimum here. The operation cost, particularly for the sorbent. And the major islands I've already explained: the absorber, reagent, and dewatering. And then key balance of plant equipment is flue gas handling, material handling, wastewater treatment, and electrical and control instrumentation. Friends, so far, this is what is the wet FGD, and I hope you have learned something. Now, for the dry and semi-dry FGD, I would hand it over to my colleague, Mr. Narendra Kumar, who will take it forward on that particular subject of semi-dry, and then I will come back again for a concluding and the comparison and the launch of innovation, the new webinar series. So please tune and stay connected. I Over to Narendra now.
Yeah. Thank you, sir. Thank you very much. So, friends, a very good evening, first of all, and myself, Narendra Kumar Prajapati. And now, today, we will know more about the semi dry FGD systems, which is also known as the multi pollutant control technology. Friends, as we know that FGD systems are also known as post combustion abatement system, SOx combustion abatement system, where the reduction in the sulfur dioxide and sulfur trioxide will take place after the combustion of the coal, sulfur added combustion of the coal. So in the semi-dry FGD technology, today we will discuss about the two kind of technology. Number one is the spray dryer absorber or spray dryer system, we can say, and next one is the circulating dry scrubbers, or we can say or we can call it CDS. So friends, am I audible? Friends, if I'm audible so far, please type yes in the chat box. Yeah, thank you very much. Thank you. So now let us move to the next slide. Uh, so can you please? Yeah, thank you. So friends, as we discuss that today, first we'll discuss about the SDA, and the pattern of the discussion will be that first we will discuss about the islands of this technology, then working principle, and then what are the features. As we know that this technology was developed in the 1970, and majority of the installations is available in the US and other countries. Spray dryer systems are recommended to install on a low combustion, low sulfur content fuels. And the major islands of these technologies are: number one is the lime slurry preparation and feeding system. Here you can see in the bottom left there is a sorbent tank, and in which what we are doing, we are feeding lime at a one point and water at another point, and agitation of this slurry will take place with the help of the agitators in order to maintain the uniform solution. And this solution is further fed to the scrubber for a reaction with the help of the atomizer. In the right side you can see there is a rotary atomizer which is placed inside the scrubber, right? And next island is our spray dryer absorber. In the green color you can see there is a spray dryer which is circular in shape, and it is having the inlet and outlet gas chambers. And the size of the spray dryer is totally depend on the gas load and efficiency, and as well as the stoichiometric ratio and the retention time, which we are going to calculate and which we are going to achieve in order to achieve the efficiency of the scrubber. And the next island is the dust collector, because after the reaction there will be a formation of the calcium sulfide and calcium sulfate as a byproduct. So after the reaction, the gases along with the particulate is going to be collected in the precipitator, or we can say dust collector. And this dust collector may be your back filter as well as the ESP. In terms, when it is ESP, then the precipitation will take place with the help of the electrostatic force, and when it will be back filter, it will take place with the help of the filtration media that we called as a filter beds. And the next and last island is the byproduct removal system. So basically after the reaction there will be a formation of the byproduct which we called as the calcium sulfide or calcium sulfate. So a small portion of the byproduct that will be collected in the scrubber, that will be taking care with a suitable transport system. So normally in industry, dense phase conveying system we are using to transport the dust from the collector to a byproduct silo. And the capacity of the silos totally depend on the storage capacity based on the power plant or based on the plant availability of the vehicles and movements. So friends, if we combine all these islands, then working principle will be that SOx laden flue gases are enter in the scrubber and the top, where in the right side we can see that gases are entering in the top, and when they get these gases passes through the spinger, and in the same time simultaneously there will be a feeding of the homogeneous solution of the solvent, which will be further passed to the rotary atomizer. So when what happens when this solution is going to pass through the atomizer, this solution will further distributed in the tiny particles. It will be further distributed in the fine mist of the droplets, and when this fine mist of the droplets will mix with the gases which is coming out from the top of the inlet, then it will create a homogeneous solution. And during this process, the reagent droplets available in the slurry will react with the gaseous pollutants that we called as a SOx, means sulfur dioxide or sulfur trioxide. There will be further reaction will take place, and the byproduct generation will byproduct will be generated. Byproducts may be your calcium sulfide and calcium sulfate, right? and and during this process there will be a further evaporation of the water droplets that will be evaporated, and as a result there will be a reduction in the gas temperature up to the operating temperature. Yes, up to the operating temperature we are maintaining this operating temperature in order to have a proper efficiency, in order to have a maximum efficiency, right? And after this reaction there will be some solids which are heavy in size will further fall down in the scrubber itself, and majority of the solids along with carried towards the dust collector along with the gas path, which will be further precipitated or collected with the help of the collector, and the clean gas is further releases to the atmosphere with the help of the stack and ID fans. So here we can see these are the reactions which will be taking care, which happens inside the scrubber. So first, calcium hydroxide, it is going to react with the SO2 and form the calcium sulfide, which will be further oxidized and form the calcium sulfate as well. There will be a direct reaction with the calcium hydroxide, and then or we called it a hydrated lime, and we get directly CSO4, which is a calcium sulfide again. So friends, there is a this is the in broad this is the working principle of this technology. And now we will move to the next slide. So can you please move to the next slide? Yeah. So friends, here we can see, no sir, just above, please. Yes. So here we can see that these are the silent features of this technology. As we know that semi-dry FGD systems are also known as the multi-pollutant system. Why we called it like this? The reason, because during this efficiency, during this process, we are capturing gases, acidic pollutants as well as the particulate matters. So in your premises, if you are facing if your existing air pollution control equipment is not performing well and you are having as well as the SOx emission, then I think this semi-dry FGD is the right solution for those kind of cases. Next feature is that since we are operating above water dew point, because the operating temperature of this kind of technology will be uh, at a 20 or 25-degree temperature above the saturation temperature. So there will be no requirement of reheating of the gases, which unlike in case of the wet FGD systems. Yes, and there is no requirement of any kind of special material which will unlike your FGD systems. So we are using here a mild steel. There is no requirement of lining, and there is no requirement of waste to energy plant, means WT plant, sorry. And we can use the low quality of water as well, because almost we are whatever the water we are injecting, it is going to evaporate, and there will be a further reduction in the temperature of the gases. Yes. So friends, this is in broad, this is the working principle and silent features of this technology. So friends, am I audible so far? If yes, please type yes in the chat box so that we can proceed further in the upcoming slides. Yes, thank you very much. So, friends, as we know that this circulating dry scrubbers is a well known in the market, and these scrubbers were developed in 1980s in the Germany, and majority of the installations are already available in the US, Europe, China, and of course some installations is available in India as well. And few of the installations are under execution, and of course some cases are under discussion also. So the main components or islands for this technology, as we can see, yes, of course, there is a circulating dry scrubbers that you can see in the red, and lime silo. There will be some lime silo, lime feeding system. There will be water tank, or we called it at the water injection system. There will be a bag house, of course, the dust collector, because semi-dry FGD system are a multi pollutants. With the help of, we can also capture the PM also. And there will be a flue gas recirculation system that we will discuss in the upcoming slide. What is the benefit of this system, and what is the recirculation system, and all those kind of things. So let us move to the next slide. So guys, there are a few islands of this technology. Number one is lime unloading and feeding system. Here you can see in the right side bottom, there is a hydrated lime. Basically, in this technology, we are using the fine lime powder as a reagent. And in any of the plant, hydrated lime is available, and or in the market is available. Hydrated lime is available with the fineness of 95% passing through the 325 mess. So what happens? Lime is available and transported in bulker, which bulkers are, these bulkers are having the unloading blowers. So hydrated lime is unloading through the blowers, and it is going to store in the hydrated lime silo. And the silo, this silo is having itself their all own accessories like vent filters, like this fluidizing system, and so on. The sizing of the lime silo is depend on the number of days for which we are looking for, efficiency that we need to achieve, and that again based on the stoichiometric ratio and purity of the lime and feed rate in order to achieve the efficiency. And just below this lime silo, there is a gravimetric feeding system. Based on this gravimetric feeding system, we are going to weight, or we are going to inject the calculated amount of the hydrated lime that we are going to inject in the scrubber based on the efficiency that we'll discuss in the upcoming slide. And our next island is the water injection system. Here we can see in the top left, there is a water storage tank is shown. So basically, we in this island there will be some water storage tank, followed by a high pressure pump and injection lances, which are installed inside the scrubber itself. This water storage tank and this skid is having the control valve. This control valve is known as the spillback valve, right? So the temperature is the main parameter for that feeding system, right? The amount of the water that we are going to inject is totally depend on the operating temperature, and that will be depends on your case to case basis. In case of coal fired boilers, the temperature will be in the range of 75 to 85, but in case of the waste to energy plant, the temperature will be in the range of approximately 80 or 95. And our next island is the scrubber. Here you can see there is a scrubber, and this scrubber is having the three sections itself. The bottom portion of the scrubber is called inlet chamber, gas inlet chamber, and the middle portion, here you can see there is a venturi. There is a this section is called the venturi, bank of venturies, right? And just above it, where we have mentioned as a scrubber, this section is called the reaction zone, where the reactions happen, and the reduction the sulfur will happens in this zone. The next zone, the next island in this system is the particulate collector, which will be a back filter or ESP, right? So whatever the dust laden SOx and byproduct laden gases which is comes from the scrubber, it is going to be further fed to the collector, where the collection of the solids will take place, and these solids will be further fed to the scrubber with the help of the recirculation system. This is the next island: recirculation, dust recirculation system and byproduct discharge system. So, friends, if we combine all three, all four, five islands, then the working principle of this technology will be: the flue gas enters, SOx laden flue gas enters. Here you can see there's a boiler is shown. The dust, SOx or dust laden flue gas enters from the bottom of the scrubber and flow upward through the bank of venturies. When the gases just come out from the venturi, their velocity will be increased, and there resulting there is a turbulence in flow. And just above the venturi, there is a introduction of high recirculation of the byproduct and the our hydrated lime. So what happens when this high velocity of the venturi, high velocity of the gases which are in turbulent form comes in the contact with the solids, which is high, big in quantity, there is the intermixing will take place, homogeneous intermixing will take place, or as a result, we will get fluidized bed in the as a characteristic. Just if we and gases are further travel to our top section, which we called as a reaction tower. Just below that, we are injecting the water in the this fluidizing bed. So as a result, after the injection of the water, as a result, there will be a reduction in the temperature of the gases from 150 or even higher. Then this temperature will further reduce to our operating temperature. Then again, the operating temperature is depend on the property of the gases, the and depends on the chloride content in the available in the gases, right? So normally the gases having their own properties. Based on that, there is a uh, dew point is arrived. So based on the dew point, there is a safe distance for the operation of this kind of technology will be 30 degrees centigrade. So if your dew point is 55, then in that case the operating temperature will be in the range of 80 or 85. So once the gases enters in the reaction zone, there will be a reaction happens, and the lime particles reacts with the gaseous pollutants and forms the calcium sulfide and sulfate, which will be further transported towards the collecting electrode, which will be further transported to the particulate collector, which will be a back filter, and where the collection of the solids will take place. And majority of the solids will be recirculated back with the help of the recirculation air slide, and few of the dust or few of the byproduct is again recirculated back to the discharge silo, because we need to maintain a bed, and the clean gases are allowed to leave in the atmosphere with the help of the stack and ID fan. So friends, now we will discuss about the major control loops. So we will go for the next slide. Sir, can you please change the slide? Thank you. Thank you. So friends, there are the four control loops which are defining the balancing of the all the parameters here. So number one control loop is temperature. Because as I explained you, there is a temperature that we have to maintain inside the scrubber in order to be a safeguard of corrosion and others. So the temperature is going to maintain with the help of regulating of water that is coming from the water injection system. Next, the control loop is SOx. The SOx, because when the gases are come out from the scrubber and pass to the stack, so there is a SEMS available already at the stack. So based on the feedback of the continuous monitoring system, there is a variation in the lime flow rate that we have to do, and based on the this exercise, we will fix the number and we will fix the flow rate accordingly. Next, our control loop is the level. Here you can see, because there is a continuous recirculation and continuous feeding of the hydrated lime. then there will be an increase in the levels in the back filter hoppers. So in order to safeguard the our internals of the bags and cages, there we have to maintain the level. So that level is going to maintain with the help of the recirculation of the byproduct. Here that you can see at the discharge end, we have mentioned here the solid byproduct which is going to transport to our byproduct silo for further disposal of. And the next is and most important, this pressure drop, this is the control loop which will be controlled with the help of the feeding of the recirculation of the byproduct. Because if there is no pressure drop, if we are not able to maintain the pressure drop, then there will be a no perfect reaction, and then we are not able to achieve our efficiency. Because here we are getting the abatement of the SOx with the help of the circulating and fluidizing as a property of this technology. And in the right bottom we can see there these are the reactions which are taken place during this process. So first sulfur is going to react with the hydrated lime, and it forms the calcium sulfide, and further which will again oxidize and form the calcium sulfate. Apart from that, during this process, this technology will further reduce the other gaseous pollutants like HCl, HF, and of course CO2. Right. So now let us move to the next slide where we will discuss about the silent features of the this technology. So friends, as we discussed that this is the circulating fluidized bed. This system is working on the fluidized bed principles. Yes, of course, there will be a high efficiency that we can achieve over the 97%. And there is a separate water injection. There is no problem like that. There is a slurry formation, and there is no separate lime slurry handling issues will be there. Next one is the complete water evaporation. So whatever the water we are injected, it will be evaporated completely. There is no slurry formation at the bottom of it. So we'll go over the next slide. Sir, can you please change the next slide? Yes, thank you. And next one is that we are using the low operating cost, because we are using the ordinary hydrated lime, and the turn down of this ratio of this technology is around 50%. And if the boiler is operating less than turn down, then we are going to utilize the clean gases after the outlet of the ID fan. Then we are going to recirculate these gases in order to maintain the turn down ratio. And apart from that, we are going to control the mercury and other volatile metals. So friends, with this technology so far, we understood that this is the well promising technology where we are going to address other gaseous pollutants as well as the particulate matters. So with this, now I'm going to hand over these slides to our CEO, sir, to proceed further.
Thank you, Narendra, so
Thank
much
you.
for explaining this semi-dry technologies, which are very, very important for the smaller type of power plants, particularly CPP and
Right.
process boilers.
Right.
And I hope that it is going to get popular in India as well very soon. Couple of plants are already in process of installation and commissioning, up to 100 megawatt or even more than 100 megawatt, 200 megawatt. But our focus is going to be on process boiler to device, or process boiler or CPPs, captive power plant, to devise a most economical system, a hybrid system or a independent dry or wet system, and to come out with a economical way of doing and reducing the SOx. So friends, now you have come to know about the wet FGD technology. In semi-dry, we know SDA, and we know now the CDS, the circulating dry scrubber. DSI, we are not discussing much here, because DSI is, yes, of course, whenever you have a very limited requirement of efficiencies, up to 40-50%, then DSI can be considered. And DSI is the most simple system. It is fitted between the ESP and the boiler, and it is a direct dry solvent injection, mostly on Na2CO3, or it is the lime also sometimes used. So that we are not discussing, because that is a very simple and basic system up to 50% efficiency. So now in the selection criteria, if you look at the economical aspects are the major thing which comes into the play when we decide which one to choose for what. So economical aspect will have capital cost, operating cost, and the technical aspect of that particular technology. Then performance aspects are defined with respect to the efficiency requirement, the sulfur quantity requirement, reliability of the technology, and the space. And then, of course, the commercial aspects, which are governed by the reliable supplier or the technology provider, whether the technology is already proven or not, and the guarantees and warranties parameter. If I say all these three technologies, which we have explained in detail, they are very, they are quite established and proven globally. But in India, yes, we are just beginning to control this SOx element on the boilers. So many people may not be aware. That is the reason we are coming forward to create that awareness among the people so that the selection becomes easier. And I will quickly run through and try to summarize the whole thing. If you look at the semi-dry or dry versus wet, and this is the comparison. The capital cost of wet is higher, the reagent cost is lower. That means the OPEX will be lower as compare if you compare the reagent cost. SO2 efficiency can be high 90s, as I told you, this 98, but in dry and semi-dry, especially semi-dry SDA, you can go 95, but you can be 98 in CDS as well. Water usage, of course, wet will have more water usage. Overall operating, this you can say this is lower, the operating cost, and in dry separation, the operating cost is slightly higher. And this is recommended for wet system is recommended for coal having more than 2% sulfur content, and it is for less than 2% sulfur content to remain the balanced approach for capex versus opex. And then byproduct in wet, it is possible, it is a gypsum which is marketable. In dry, it is mostly used for landfilling so far in India. And SO3 emissions in wet system, yes. In dry system, it is not there, nil. As far as Enviropol is concerned, we have experience of doing 4 projects of different kind. And latest in the series of this is a caustic scrubber being done at Dangote refinery in Nigeria. And it is a process FGD with 215,000 meter cube per hour of gas flow. And these are a couple of photographs. I will just run through the actual photographs so that you are aware about the sizing, the type, and you can correlate with your plants. This is the absorber. You can see the size of this absorber for a caustic based scrubber for Dangote. This is for a small petcoke fired boiler, 30-ton boiler at Reliance. We had a completely in-house technology developed with a vent tray, caustic as well as lime. It's a dual alkali system for a smaller size of boilers, having very high input concentration of SOx. Here it was designed for petcoke where the input is 7,000 milligram, and we could achieve outlet of 197 with a in-house designed completely low-cost solution where the venturi section was operated on lime and the tray scrubber was being operated on caustic. And this also had a reheater in the form of a steam reheater on the top of the scrubber. This is the project under installation at Nigeria, and this is the absorber. You can see a big absorber of 60-meter height. This is the photograph of absorber under dispatch to Nigeria. This is the stack mounted on the absorber itself. And this is the this tank, sorbent tank under dispatch. Recirculation pump for caustic scrubber. This is dual alkali system which I was talking about for a petcoke fired boiler, where we have a venturi scrubber, variable throat venturi, having the lime solution, and followed by the multi-stage tray scrubber with a reheater operated on caustic. This is all the diagrams, and you can see some running photographs. This was based on a sludge ash pond base. There was no recovery. The one side you have a caustic based effluent, and other side you have a lime based effluent. This is the Reliance certificate performance and the data, testing data. And if you look at the testing data, we got about 197 milligram of SOx emissions. And we have a global partnership from a European company on wet and FGD, wet and dry FGDs for bigger plants. This is the some photograph from our counterpart for a 660 megawatt in Europe. This is another one for a process plant, lead manufacturing plant with a 45,000 meter cube per hour of gas flow, where the SO2 concentration was less than 400 milligram per nm cube. And you see how the gypsum is produced and dewatered on horizontal vacuum bed filter. I'm just running this video. So this is the gypsum with a moisture content of less than 10%, and which is readily marketable from a wet FGD plant. And if you look at the system capabilities of wet FGD, the SDA and CFD, you can just see here that CFD is looked to be the most versatile in terms of the most green part, the advantage. This wet FGD has got many reds, the disadvantages in terms of water consumption or fine particulate capture, high SO2 capture and all. And this gives you a brief, I mean, at a glance, you can have a selection criteria, you can base your selection criteria. But having said that, the selection of particular technology for a particular plant is not so easy. It has so many variables. So my recommendation for all of you would be to consult an expert when you decide for a particular technology, because there are plenty of variables which will decide the operating cost, which will decide the capex for the complete system. So, and once you select a wrong technology or an inadequate technology, you have a problem forever. So my recommendation would be to contact the expert, maybe some consultant or maybe some supplier you trust, who can make a feasibility study for you comparing all type of technology for capex, opex and life, and then take a call. Because it is really a difficult exercise. It is not so easy to select either of the one. But these are the basic parameters which can be looked into and which can be kept in mind when discussing even with the expert or with the consultant. Because unless and until you as an operator has got a good knowledge of those parameters which are supposed to be considered for the selection, then it will you will be totally dependent on the other person. So my recommendation, you should know everything, but still you have a second opinion or the consultant hired for selecting the right technology for you. And this is the comparison between lime scrubbing, magnesium scrubbing, sodium scrubbing, and ammonia scrubbing. And if you see the reactivity basis, the lime scrubbing has got a low reactivity, and the highest is the sodium and the ammonia. But again, this the cost of sorbent is very high as compared to lime or magnesium here. And on the removal efficiency, the highest of course is sodium. Again, the caustic is the highest, and the ammonia is also equally good. So this is the comparison. And on the operation cost, definitely the capital cost of wet system is going to be high, as well as for ammonia system it is still higher. But the lowest cost is the sodium scrubbing on the capital side, because the scrubber dimensions and the scrubber type is very, very simple for caustic scrubbing. But on the effluent side, the caustic scrubber is the most difficult to operate, because you have all the dissolved solids and you need to have a proper evaporation system for producing the caustic, the salts or the solids from the effluent. So, and the easiest effluent treatment is from the lime, where you can generate a byproduct of gypsum. Correct. And if you see the conclusion of all these, that FGD process is a reliable process and it is already proven to reduce the emissions. These three are the most prevalent technologies, as we have explained, and they are quite established. Nothing to worry if you select the right partner, if you select the right technology provider for you. And the key, basic key is to select the most adequate technology out of these three based on the parameters we have given to you at a glance for a first step study. And then after that, hiring or contacting the partner you trust or the consultant you trust for vetting that selection is right or not, and then going ahead with the technology, particular technology. So the selection requires a careful study. Correct. So friends, this is what it is as far as the today's webinar is concerned. But before we take up the question and answer on today's webinar, I'm going to announce a surprise for you, a powerhouse of knowledge, the new webinar series on innovations. We are going to have this webinar series. This webinar series will consist of total 4 webinars starting from February to March. And these 4 webinars are, after this end of this 4 webinar, there will be a quiz contest as we did last year. And the winner of the contest will be rewarded suitably as we did before. So I would just highlight the topics of the 4 webinars we are bringing to you in February and March. So the webinar which is going to be there on innovation, innovative solution. The first one is going to be specifically for pulp and paper plant, or the plant which are using biomass as a fuel. So it is an innovative solution for waste heat recovery and flue gas cleaning in pulp and paper plant. We will be having a very specific flue gas cleaning system here for black liquor fired boiler or recovery boilers and paper plant. And the first part will cover how the flue gases from the captive power plant of the paper industry can be utilized for waste heat recovery. And the second is going to be on biomass drying, especially the case study we will be presenting from 2 sugar plants in India, very prestigious sugar plant which are operating the bagasse dryers, and the case studies, their result over a period of last 2 to 5 years of operations. And then the third webinar will have an innovative solution to upgrade your existing air pollution control system. Most of us or all of us are having some system. Now replacing that system for upgrading the efficiency is a big cost, big shutdown, and it is a high capital cost. So we are trying to give you solutions, seeing the problems which are, I mean, there are a lot of queries coming to us from various customers that we have this, but we don't want to discard this completely. We want to upgrade this. Can you reduce from 100 milligram to 50 milligram? So we have summarized all such problems which are coming from the industry, and we have specifically for all the users, we have found out some solution to reduce the emissions within the existing system with the minimum investment. Be it ESP, be it back filter, be it existing scrubber on a multi-cyclone, you have something or the other to add upon as a secondary system along with the main system, so that your shutdown time is minimized, you are future ready for the new pollution control norms, and your capex is reduced. So third webinar is going to be very interesting and innovative. And the fourth webinar is going to be dedicated to the sugar industry, where the norms of 150 milligrams are expected to be down very soon to 50 milligram per nm cube on bagasse fired boilers. So we are trying our best to make the sugar factory future ready with minimum investment to meet 50 milligram from their existing system with couple of more innovations and with couple of more additions and generating revenue out of it. So if you look at the dates, please block your calendar right now. We will be sending you the time to time all these you will get the post on social media as well as on email and broadcasting, but you can block your date. On 3rd of February we are going to have the first webinar, followed by 10th, 17th and 24th. And 24th of February itself, we are finishing all this in February itself, and 24th of February we are going to have a quiz contest, and the quiz contest will be a MCQ type of questions, only 10 questions from all these 4 webinars. And whosoever is coming first, stood first on this quiz contest, the results will be declared within 5 to 10 minutes after the quiz contest. It is going to be for only 15 minutes. So guys, please fasten your seat belts and be ready for these webinars and make lot of notes so that you can appear in the quiz contest, and the winner will be rewarded suitably with a lot of rewards from our side. There are green heroes merchandise and other things. So thank you so much, friends, for your patience hearing. And I am very happy that most of you are connected till end. And in the last, we always say that pollutants are inevitable, but pollution is not. So thank you for your patience and thank you for your learning. And the benefits from the innovation which are going to come is these which are listed here, that we will be sharing knowledge, recent development, we will be highlighting experience sharing, and how to meet more stringent norms from existing system, and also how to generate revenue from APC system. So I'm sure it is going to be very, very useful for all of us to add knowledge from these webinars. So I expect every one of you to be participating in these webinars. So thank you so much. This is what it is. And now we will be taking up the questions from the Q&A. And if something is left out, please do not worry. We will be sending you the reply to the questions, because time is already, we have overrun by 10 minutes. But still, we would like to reply a couple of questions. If anything is left, we will be contacting you with one-to-one reply. Plus, one more thing, I would like to apologize for one thing today, that because of some technical problem, though we had a registration of 200 people, but some people could not join. But nevertheless, we are going to send them the recording very soon. And we will be contacting them directly, whosoever has not been able to join this. So let us now have the question and answers and see in the chat box. Okay, so the first question I'm taking up, do CDS system require a minimum inlet gas temperature for functioning? Narendra, would you like to reply to this question?
Yes, sir. Of course, there will be a minimum temperature, sir, and the temperature will be at least 25 to 30 degree above the dew point temperature. So, yeah.
Okay, and next question is coming out. We do not have many questions today. Anyway, I presume that most of things are clear, and I'm just trying to figure it out. If we have any questions, somebody has put it before the question and answer. Yes, there are a couple of questions. In wet scrubber, you are using limestone, and in SDA, you are using lime. Different chemistry, different reaction. This question is from Mohan Dogare. Uh, Dogre sab, you are referring to SDA and CDS, not very clear. I will speak to you one to one. In both the cases, we are using hydrated lime, whether it is SDA or it is CDS. But in wet FGD, yes, we are using limestone in most of the cases. And the chemistry, as you have seen from the screen, it was different for limestone and it was different for hydrated lime in dry, semi-dry system. And now another question, if you RPC with sulfur content 9% used, then which is the emission of CO2 gas flow rate? Uh, Narendra, can you understand this question from Mr. RB Singh? I'm not very clear. If you can reply. If you if your RPC with sulfur content 9%.
Sir, then in that case, we need a gas flow rate and as well as the fuel feeding rate. Based on that, we can calculate the inlet SOx which is coming out the
Yeah,
inlet of.
and just to add on this, you can just visualize that 1.5% creates approximately 1500 milligram per nm cube of SOx emissions.
Right.
So 9% will accordingly be, you can prorate it, but exactly we can calculate when we have the complete composition of the gas and the gas volume. Then we can calculate it for you. Next question is again from Mr. Mohan Dogare. Can we use your wet scrubber in spent was slow fired incineration instead of ESP or back filter? The wet slurry obtained after wet scrubbing, no limestone but only water, can be used for potassium recovery using. Yes, Dr. Mohan, we have discussed this point and I'm happy that you have brought it up here. This can be used. Nobody has used so far because the spent wash firing incineration is basically to eliminate the effluent. So nobody wants to go for wet system. But the moment you have your potash recovery from the ash, and then it makes a sense because ultimately you are making the slurry again to remove the potash from the ash. So combining these two could be a good solution for all the operators of spent wash. I will be in touch with you very soon on this with a customer knowing and showing interest on this. Thank you, Dr. Dongre. So friends, we do not have many questions. If you have some questions left out, you can please put it on our email or on the social media. We will be happy to connect. Okay, okay. I'm coming. There are some more questions. I'm sorry. I'm sorry. For pet coke application, which system you are preferring? This question is from Rajneesh Ramakrishna. You know, the pet coke is having a very high sulfur content, and we had measured it at Reliance Hoshiarpur to the tune of 7,000 milligram. So there we have used dual alkali, but caustic based system in pet coke could be less capital intensive, but definitely it will have a little high operating cost, and the disposal of effluent will have to be treated properly. But if you look at the capex, the best system for pet coke is going to be caustic, where the reactivity is very, very high. The size of the scrubber is going to be smaller and you can have very good efficiency. Or you can go with a dual alkali as we have done it for Reliance, where we have brought it down to below 200 milligram. Okay. And then okay, next question. Yes, Mr. BN Singh has given a feedback. Narendra, I think there is some typographical error on gypsum formula. You can correct it for the next time. Thank you, Singh Saab, for your feedback. And then next question is from Mr. Pankaj Lamba, who says that, are you measuring density of limestone slurry among wet FGD? If yes, how? Okay, yeah, can you reply? Would you like to reply, Narendra, on this question?
Uh, for density for lime slurry in case of wet FGD system, sir?
Yes, it is
Okay.
measured.
Basically, this is the calculated solution that we are going to feed because we are weighing the lime in the before feeding into the this feeding system. Means dosing system. We are maintaining the based on the feeding rate. We are maintaining the slurry percentage. Yes, of course, there is a provision available, and yes, there is a provision for the measuring of this concentration as well.
Okay, next question. Any future planning how to use gypsum other than cement industry? Yes, not the planning is not at there so far at our end, but definitely yes, we can look for more innovations of using gypsum other than cement. It is normally being used in other places, as I mentioned to you. It is for plaster of Paris. If the quality is good, the gypsum boards are used for domestic and building in the real estate industry. And next, what is the hydrated lime consumption per megawatt per hour? Prabhatji, are you talking of semi-dry? If yes, then it would be different. In CDS, you have a data, Narendra, then you can reply now or you can
Uh,
send it per
I will send
megawatt.
separately, sir, because currently I
Okay,
don't have a.
Prabhatji, we will come back to you. We do
Yeah.
not have a ready-made data available on this. The backend team, please note these questions wherever the data is supposed to be given. Let us make sure that it reaches to them in next 48 hours. Thank you, Prabhatji. What will be the purity of limestone required for FGD system? As high as is better, but normally 85 to 90% is the recommendation for purity. Yes, Singh Sahab, you are right. It is 83 normally we get, but in some cases we have got 85 plus for a better reactivity. What is the use of byproduct from hydrated lime? It is normally being used for land filling so far. Right, Narendra, or you want to add
Yes,
something?
of course, and sir, apart from that, there is a further investigations is going on where we are looking for the further utilization of this byproduct, and few peoples are still working on this, and we can mix this byproduct with the fly ash for further brick manufacturing and all those kind of
Yes,
things.
lot of I think lot of
Yes,
agencies are working to utilize this
right,
from semi-dry FGDs, but still it is in a fluidic stage. People are
right.
using it for land filling.
Yes. And sir, just now one question came per megawatt lime consumption. Basically, as per the process calculations, it depend on the what is your sulfur content in and what you are looking for the as a outlet. So, being the
Okay,
efficiency, we need to calculate the lime and based on the stoichiometric ratio, which will be vary from the efficiency as well. So there is no straightforward correlation that per megawatt. Yes, there may be some cases that some CPP are using pet coke and someone is using the low high grade coal. So in that case, the sulfur content may vary, and the efficiency also may vary. So if we are having any special kind of input firm parameter, then we can proceed with this.
okay. But let us talk to Prabhatji and take the
Yes,
input or give him the generic data for that.
yes.
Okay, thank you, Mr. Prabhat. We have density meter radioactive based for slurry. Yes, you are right, Mr. Singh. Radioactive based slurry for density. Can we use instrument air in place of fluidizing air for absorption system? Yeah, question is from Manish Singh. Can we use instrument air in place of fluidizing air for absorber system? I think if the air is dried and dehumidified, you can definitely use if the pressure and quantity is sufficient. Okay, gentlemen, thank you so much. We are closing the webinar of today. See you on 3rd of February for the next first webinar of the next webinar series, which is on innovations. And see you there. Stay fit and keep following the protocol of COVID. All the best and good night. Thank you so much. Thank you so much.
Thank you.
Thank you so much. Okay. Thank you, Anilji, for the good clap. Thank you. Thank you. Thank you, Ajay. Thank you, everyone. With over 370 installations across 20 countries, Enviropol have been able to clean the air by over 12 million tons of solid particulates and 250 million tons of gaseous pollutants. This has made a positive impact in better agricultural growth, health and safety of human beings in the vicinity of the factories, besides creating employment and byproduct. Enviropol has been pioneer worldwide in supplying various new technology in the field of air pollution control. It is rated #1 amongst few Indian companies in the entire spectrum of air pollution control business.